Hello everyone. Today I'll be sharing some of our research about utilizing EEG, eye gaze, and learning analytics to investigate student engagement in a VR classroom. So over the past few years, we've started to see traditional methods of instruction begin to be slowly replaced by various online methods of instruction. And this trend was only further accelerated by the pandemic, as we all know. As institutions try to adapt to these changes, gaining a better understanding of how students and instructors interact with online learning environments has become imperative. One of the most interesting questions seems to be about gauging how students engage with classroom in an online learning setting as opposed to face-to-face instruction. Engagement itself is a very complex, dynamic, and multidimensional construct that has various components. It's more difficult for instructors to assess student engagement in an online setting as opposed to face-to-face instruction, where student behaviors like nodding and taking notes can be directly observed. This is even more true for students that view pre-recorded content without any real-time interaction with the instructor. How then do we really understand student engagement? It's important for us to look at engagement due to the link between it and learning outcomes. For instance, a model that we mentioned in our work called the ICAP framework says that as the level of engagement required by an activity increases, the learners need to engage in more constructive cognitive processes. Different kinds of cognitive processes lead to different kinds of learning outcomes. So passive learning activities, such as simply listening to a lecture, lead to the most superficial learning, and interactive and constructive activities where a learner is actively involved in the learning process leads to the most robust learning outcomes, where they gain flexible knowledge that's transferable across contexts. The problem with current research on student engagement, be it about online learning or otherwise, is that it relies heavily on self-report data, where researchers prompt students occasionally to report their level of engagement at different points during a learning activity. So as you can see below, there are a few sentences, and the students have to rate how they're feeling at that particular moment in time on a scale. And this poses a few conceptual and methodological issues. Firstly, students might just not be aware of their exact level of engagement, and so it's not a very reliable measure, or their reports may be biased because they want to come off as more engaged than they really are. Second, it interrupts the learning experience and makes it artificial. So when you're in an actual classroom, you're not going to be asked to report how engaged you are every other minute. Finally, in order to generate usable data, these attention probes have to be used frequently, and that in turn could have an effect on student engagement, the very thing that we're trying to measure. Given these limitations of self-report measures, there has been growing interest during recent years in various behavioral and physiological measures of attention and engagement, like reaction time, eye tracking, and heart rate. However, previous studies employing these techniques seem to be limited by their use of artificial stimuli and tasks that are far removed from the attentional challenges of real-world classrooms. Think sitting in a lab instead of listening to a lecture. To mitigate this problem, in this project, we propose to investigate student engagement in an immersive VR classroom environment. Recent developments in VR technology make it possible to create authentic and realistic learning experiences while still maintaining experimental control over various components of the environment. So a VR classroom would present the optimal trade-off between limited experimental control in real-world classroom study and the ecological validity of lab-based research. A little bit about our study design. The study will employ a 2-into-2 within subject design. The first factor will be the type of instruction, active versus passive. So the participant will have to watch 2 7-minute lecture videos. For one, they will be passively watching the lecture, and for the other, they will be asked to respond to open-ended multiple choice questions presented throughout the lecture, which would make them actively engage with the content. Some of the things we're going to be doing in order to leverage the fact that we're using VR tech is manipulating the kind of distractors in the classroom, the layout of the classroom, so heavily decorated versus a minimalistic environment, and also adding in some manipulable and interactive elements in the classroom, such as reading material, a VCR tape, etc., some of which I'll be showing you soon. Participants will be placed within a fully immersive head-mounted display. After loading into the classroom, they'll assume the perspective of a student at their desk. They'll be able to turn their heads and survey the environment and also interact with elements of the environment using handheld controllers. We'll be using a Vive Pro with a built-in eye tracker, and at the same time, they'll also be wearing a mobile EEG headset. I'm going to be showing you snippets of what the actual environment looks like in just a minute. It's been designed and programmed using Unity. The teacher and student avatars and the classroom scene have been constructed from commercially available assets.
Primates. So when we look at our group of primates, the great apes, we see many different kinds of locomotion primates. So when we look at our group of primates, the great apes, we see many different kinds of locomotion being employed. Knuckle walk.
So that was a snippet of our VR classroom environment and ideally what a participant will be expected to see. Do keep in mind though that this is a prototype and we're still at our development phase. Moving on to expected findings. The EEG analysis will mainly focus on alpha bands and the theta-beta ratio, both of which have been previously associated with attention and engagement. With regard to eye tracking data, we'll measure fixation duration within predefined regions of interest like the instructor, the slides, different components of the class, etc., and also fixation dispersion. And both these measures have been recently shown to reflect engagement. Finally, our pre and post test will also help shed some light on learning outcomes. We expect to find higher user engagement in the active learning condition and also just gain a deeper understanding overall of how students interact with and learn in a virtual reality classroom. So I'd like to conclude by saying that the VR classroom will allow us to address research questions that can't be easily tested in traditional lab-based settings nor in classroom-based research. We hope that this project will support the design of instructional technologies that can be tailored to the needs of individual students and promote education equity by supporting students who might not thrive in traditional classrooms. And we hope that findings from this line of inquiry can inform the design of future novel evidence-based instructional methodologies that leverage the unique benefits of a VR learning environment. Thank you for letting me share this project with you all, and I look forward to any and all questions or feedback. Thank you.